Okay, we're going to take a look at one more application of exponential functions. And in this case, we're actually looking at exponential decay because you can see that the base here is between 0 and 1. So when I multiply by that 1/2 repeatedly, I decrease how much there is. And this is good news that it's decreasing because this is modeling the nuclear reactor accident in Chernobyl. So this was from 1986 that this occurred, and the explosion spread radioactive chemicals like plutonium hundreds of square miles. And so we actually have this model that represents the amount of plutonium in pounds that remains T years after the incident. And that means that as we want to investigate different things about this, we're going to be able to use T as how many years it is after 1986. So this isn't just T is meaningless. It's a certain random number of years. It's years after 1986. So when T is 1, it's 1987. When T is 4, it's 1990, etc. So if we want to figure out the initial amount of plutonium released, then that is when T is 0. That's 0 years after the incident. So we have P of 0, which is equal to 10 times 1/2 to the 0 divided by 24,000. Well, 0 divided by 24,000 is simply 0. And I'm going to take the exponent before I multiply by 10. So 1/2 to the 0 is equal to 1. And so therefore this is 10 pounds. So a total of 10 pounds of plutonium was released when the incident occurred. And so what we're going to use is this model to try to figure out how much plutonium is remaining in Chernobyl this year. So right now, the year is 2020, and that means that T is 34 years after 1986, because, 14 years to get to 2000 and then another 20 years later. So we're going to find P of 34 by simply plugging that into the function. And you can type this all into your calculator in one sweep. And the unfortunate result is that there's still 9.991 pounds of plutonium. So we started with 10 pounds and there's still 9.991 pounds. So this is exponential decay. But do you notice that my exponent up there isn't just T, it's T divided by 24,000. So it decays very, very slowly. So let's suppose we jump way ahead and we try to figure out, okay, how much is left if 50,000 more years go by? That's a huge amount of time, long after probably humanity is around anymore. And we end up plugging in 50,000 to this. And we get 50,000 divided by 24,000 in the exponent, which if you type that into your calculator, you get approximately 2.3597 pounds. So it's still around. It's not completely gone, but it is a lot less. But this is kind of the time frame that we're talking about as far as getting rid of the plutonium. Now, if you graph this on your calculator and you want to estimate how many years must pass until only about 1 pound of plutonium remains, then I'm going to have some guidelines on here of like a helpful window, and then I'm just going to switch over to a different video for you to see what this looks like. So this is going to be X min for your window settings is 0. We want to go really, really big for X max because we saw that even at 50,000 years going past the incident, there was still a lot of plutonium left. So let's go way out to 150,000 years. And I think it's helpful to have the X scale show us a little bit of what's going on. Maybe have the X scale be 20,000. We'll have Y min be 0 because we're never going to have negative amounts of plutonium. Y max can be 10 or 11 because we only ever had at maximum 10 pounds of plutonium as output. And let's have the Y scale be 1. Now, I'm going to walk you through it, but if you want to pause this and just try it yourself on your calculator, what you're going to do is go to your menu and type in the function. Just make sure that all of this t divided by 24,000 goes in the exponent. And we're going to try to find out when about 1 pound of plutonium remains. Now, in my opinion, the easiest way to do that, if we want to find out when this is equal to 1, then we're actually trying to find out when this is equal to 0. And that's kind of a common trick that we can use here because our calculator is really good at finding zeros, not quite as good at finding like when the function value is height 1. So I'm going to have you put this into your calculator and find the 0. And that's not going to give me when there's 0 plutonium. That's going to give me when this is true, because that is equivalent to when this is true. So if we can find the 0 of this, then I have found the answer to this. All right, so I'm wrapping up the video here. I will post a calculator video with this, so you should just look for the calculator video so you can take a look.